2018 FRQ number 4, part D. So this time they give us the height of the tree. Now they give us a function. So before all we had is a table. They like to do that sometimes. Here's a table. Now we're still talking about the same thing, but now we're going to give you a function. You could check to see how well that matches, but who knows? It's certainly not worth the effort. Where x is the diameter of the base of the tree. All right, so they're giving the height as a function of the diameter of the base. You got to really track the variables here. Now, when the tree is 50 meters tall, the diameter of the tree is increasing at a rate of 0.03. That's the diameter of the tree, and that diameter of the tree is x. All right, and then it says, what is the rate of change of the height of the tree with respect to time? Okay, so what we can see emerging here is a related rates problem, because they're giving us a rate and they're asking us for a rate, and they gave us an equation that connects the two variables. So we have an equation connecting the variables, and we have different rates. Now, the variable that they didn't mention very explicitly here is time, though. We need it with respect to time. So what we have is this, g of x equals 100x over 1 plus x. But what we need when we're asked for the change of the height of the tree, and the height is g now. Why did it become g instead of h? I don't know, but it does. All right, so the height of the tree is g, and we want that with respect to time. So the thing that we have to watch out for is not calling that change of the height of the tree with respect to time, calling it g prime, because there's another variable here, which is x. So we have three variables, g, x, and t. And so if we say g prime, we're not being explicit about with respect to which variable are we taking a derivative. So what they're really asking us for is dg dt. All right, and what they've given us here is the diameter of the base is increasing at a rate of per year. So this is dx dt equals 0.03. So in addition to our function here, we have dx dt equals 0.3. This is 0.03. All right. And our question is, what is dg dt? Right? So if I do the derivative, so basically this is a related rates problem. I've got an equation relating to two variables. I'm going to do a derivative, but my derivative is with respect to t. That's what I really have to watch out for. So over here I'm going to have dg dt. I'm not going to call it g prime, because do I mean dg dt or dg dx, right? So then over here I'm going to do this derivative. That's a quotient rule. So we're going to go f prime g, so that's 100 times 1 plus x, minus f g prime, so that's 100x times 1 over g squared, which is 1 plus x squared. Now that's just doing my quotient rule, okay? But because my derivative is with respect to t, and this function is a function in terms of x, I need to add on here dx dt. All right, so it's, unfortunately I squinched that in there pretty badly, but so we need this dx dt. That's a chain rule. All right, and so we're going to need to use that to get full points. And also, you sort of have a hint here that we're going to have to do that. Like, why are they giving you dx dt? It's because of that. All right, so now we can sort of simplify this a little bit, and dg dt, because up here the 100x and the minus 100x cancel out, so we just end up with 100 over 100 over 1 plus x squared dx dt, and that's what our dg dt is. All right, now I want dg dt. It says when the tree is 50 meters tall. So that's when the height of the tree, when g of t equals 50. So that's another thing that they're giving us here, is at the time when g equals 50. All right, so now we can plug things in. Like, we already know that the dx dt, all right, we already know that was given as 0.03, so we can put in 0.03 for that. So the trick is, what am I going to put here? I know I have 100 over 1 plus something squared. All right, but what is that x? What's going to go in there? Well, they told me g, but they didn't tell me x, but they did give me an equation relating g and x. So this is one of those cases where I have to solve for the missing variable. So basically, I can, since g is equal to 100x over 1 plus x, that means that using my g equals 50, 50 equals 100x over 1 plus x, so 50 plus 50x equals 100x. Subtract the 50s from both sides, the 50x's. 50 equals 50x, and we get x equals 1, and that is what we can plug back into there, x equals 1. All right, and then we just have 100 over 4. I mean, really, we can actually leave it right here. Right, so we can leave it here, 100 over 1 plus 1 squared times 0.03. We've already got full points right there. If you can't resist simplifying, that's 25 times 0.03, so that equals 0.75. We don't have to put units because they don't say it. They don't say units. But if they had asked for units, all they asked is what is the change of the height with respect to time. Here's why they didn't ask for units, by the way, is they gave you the units right here in meters per year. So it's not like they are ignoring the units completely. They're just saying, I don't want you to think about that. Here they are. It's meters per year. So if you want, you can put meters per year, but you've already answered. If you say 0.75, that is the rate of change of the height of the tree with respect to time in meters per year. So you don't have to reiterate that it's meters per year, but if you want to make Mr. Parker happy, there you go, it's meters per year.